We are very happy today to receive two guests here today to discuss precision livestock farming. I want to welcome all of you who are now in the room. My name is Diana de Oliveira. I am a professor in farm animal welfare at Linnaeus University here in Sweden. And in Pathways project, I work in the management team with the coordination together with Dr. Lawrence Smith and Halvard V. And I'm very happy to be moderating today the discussion in this amazing topic, which is very interesting and timely, as I was just talking to Sabia and Mikael. And I hope that today we can learn a lot from you guys and that we can advance these discussions, because this is such an important topic when we consider livestock farming and all the technologies that are coming in, and how can we include this in on farm level, and all the opportunities and threats that we can face with these new technologies. So today we have two guests. The first one that will talk is Xavier Dias de Otalora Aguirre from the Institute of Animal Science and Technology at the Polytechnic University of Valencia. And then we will listen to Mikael Normark. He's a senior researcher at the Department of Electrical and Computer Engineering at Aarhus University in Denmark. So without further ado, I pass the word and welcome Xavier to start our conversation today. Welcome.
So thank you, Diana. Good morning to everyone. Thank you for joining. So as Diana has said, I'm Xavier. I'm working here at the university, at the Polytechnic University of Valencia in Spain. And I'm going to start the presentation. I'm going to start sharing my screen. So if you could please tell me if you can see the proper screen.
Yes, we can see it.
Perfect. Thank you. So basically what I'm going to do is to give an overview of precision livestock farming technologies and how these technologies can improve the efficiency and the sustainability in animal production. So first of all, to give an overview of what is happening right now in the livestock sector. As you probably are aware of, there are multiple challenges that they are derived from the increase in the demand of animal source products. So as you can see in this graph from FAO, during the last decades, there has been an increase in animal protein demand that is probably going to be followed this trend in the next decade in Asia, Americas, and Africa, and is going to keep stable in Europe and Oceania. This increase in the demand of products leads to a higher production and consumption of animal source products. And this, in consequence, could cause problems to the environment, to the economy of our societies, and also could affect how societies react to this increase in production and consumption. Furthermore, as you probably are aware of, we are living in a climate change crisis. And this also is a key burden for the sustainable animal production in our societies. In the last decade, we have been experiencing a constant increase in the temperatures of our planet. And this increase is, depending on the scenarios that we look to, is expected to keep increasing. This increase in the temperature of our planet also has effects on animal production. For example, we can see how the increase in temperature could affect the animal welfare of our farms, livestock farms. Also could have an effect on the productivity and efficiency of our farms. So we can see how the increase in temperature could affect a lower production of our livestock farming systems. And also these problems, combined problems of animal welfare, and also the problems that climate change sets to the animal productivity, could have an effect on the quality of life of our farmers. So there's more work to do, and the quality of life of the farmers could be also affected. So how, as researchers from the scientific world and also the governments can, let's see, tackle this problem of climate change and the increase on demand? So as we are here meeting for, precision livestock farming is a key tool that can be used to offer solutions to improve the animal production sectors and make it more sustainable. So how precision livestock farming works? For me, it works in 4 key pillars. The first big pillar is that precision livestock farming technologies help to improve animal welfare. So there are multiple technologies that can help to reduce, for example, heat stress in farms. Another pillar for me is that precision livestock farming technologies could help to increase the production efficiency of livestock farming systems. In this case, we can reduce, for example, the use of inputs, and this reduce of inputs can help to increase the efficiency of the farms, producing more or less the same quantity of food with less input. So I think that precision farming systems could cooperate to this pillar. Another aspect that also it's important to consider is that precision livestock farming also cooperates to reduce the workload of the farmers, and by reducing the workloads and also the worries of our farmers, we can improve their quality of life. And last but not least, precision livestock farming also helps to reduce the environmental negative impacts of livestock farming, both in Europe and at the global scale, but by, for example, controlling the emissions of our farms and tackling the aspects that they are the causes of these emissions. So we have seen the main pillars that precision livestock technologies in livestock farming tackle, and we have a lot of technologies that can be used to address this and to assess these pillars. First of all, we have the basic, how we monitor the animals. So there's plenty of sensors available right now to assess, for example, how the behavior of the animals are in the farms. So we have, for example, collars of the animals. I brought some toys here to show you. For example, what I have in my hands is a collar that can be put in goats and is used to measure the movement of the animals and the behavior of the animals inside the barn. We also have some pedometers that can be used mostly in ruminants to measure how they behave in the farms. And also in ruminants, they are commonly spread sensors to monitor how the physiology of the animals are. Here in the picture, you can see, in the picture to the right, you can see some ruminal bolus that can be introduced inside the animals to monitor, for example, the food intake, water intake, and pH of the rumen of the animals. Another aspect that also precision livestock technologies are commonly used for is to monitor how the environmental condition of the farms are. One aspect that are used is to use and that is measured is the emissions of the farm. So we have wireless sensors and wired sensors. Here I brought you, as you can see in the picture, here is a wireless sensor that can be used to measure the concentrations of ammonia emissions in the barn, in animal housing systems. Right now at the university, we have these sensors. There are plenty of marks and trades that also develop this sensor, but it's really handy because you can move it across the barn and you can select the area that you want to measure. We also have sensors to measure temperature and relative humidity. That's something really important to then calculate heat stress indicators in the farm. And one aspect that is not commonly used to address is the noise of the farm. Farms normally are really noisy environments, and the noise of the farms could affect the animal welfare. So using devices such as, for example, microphones, we are able to monitor the stress of animals produced with noise, and we can adjust the management practices that we use in the farm based on this noise. Another aspect also is the production efficiency. Right now, there are a lot of devices that can be used in farms to adjust the amount of inputs that they are used in the farm to produce in meat or milk, or derivatives in this case. So I brought here 2 examples that for obvious reason I cannot bring to the presentation in person, that they are automatic feeders. So I don't know if you're familiar with automatic feeders. What they do is to provide an adjusted amount of feed to the animals based on the weight of the animals and in the stage of living of the animals. So in this way, we reduce the waste of feed that is provided to the animals, and we cooperate to the efficiency of livestock production. And another device that commonly used, and you can see more and more in this case, mostly in dairy barns with dairy cattle, is the automatic milking systems. In contrast to common or traditional milking parlors, automatic milking systems, they provide more animal welfare and less workload to the farmers, as the animals can go to the milking time freely. They are not pressured to, or they don't need to adjust to certain hours of the barn. And there you improve the animal welfare of the animals. And then also the farmer gets more data from the milking system. One thing that needs to be considered where PLF is the data, as I'm going to say after, is really important. So data is the new money of the future. And with data, we can monitor the animals and we can make better practices. So I also brought here some examples that they are currently developed and or currently under development, in this case, in the farms that we have here in Spain that we cooperate with here at the university. As you can see with letter A, you can see the sensor that I show in the lower picture that monitors the movement of the goats, and we are able to monitor how the goats' behavior. And also in the picture number 8, in the upper picture, you can see how the animals, in this case, dairy cows, are monitored and their behavior is monitored. And they cooperate, for example, this sensor to assess animal welfare in the sense of panting. For example, here in Spain, we have a huge problem with heat stress. So this sensor allows us to identify if the animals are panting. That is a really good indicator for heat stress. And therefore, the farmer, based on precision livestock technologies, can adjust the practices to these heat stress situations. In the middle set of the pictures, we can see in the upper picture a system that I'm going to explain afterwards that's able to count the animals that they are, for example, in a barn, in a feedlot, or in another area of the farm. And in the back picture, in the lower picture in B, we can see how a computer vision can be used to tracking animals inside the barn to monitor also the behavior. So there are two different approaches to monitor behavior. One is using sensors and the other one is using computer vision, and both of them, they are considered precision livestock farming technologies. And last but not least, in letter C, you can see how sensors, as the one I saw, are used to monitor, for example, emissions or concentrations in the farm. So afterwards, the farmer can take better decisions of ventilation, for example, based on PLF technologies. Probably one of the examples that you are more familiar with is virtual fencing. So a couple of years ago, the people and researchers, they started to develop systems to make better use of the grasslands, mostly on extensive systems. Not only PLF can be applied to intensive systems, also to extensive systems. So in this case, here in these pictures, you can see how virtual fencing works. So the cows, in this case, they have a collar installed on their neck. This collar has GPS connectivity and also solar panels. And then the farmer can draw through an app in the mobile phone an area that they want for the cows to use. And then they make better use of this grassland, because the cows, according to some noises and some stimulus, they keep inside the area that the farm has drawn in the app, and they optimize the use of the grasslands. So one of the things that also is becoming more and more relevant in this area of PLF technologies is how we can use all the data that we have been collecting through PLF technologies to address the problems and to identify solutions. One of the most interesting sites from us from here at the university, and that we are intensively working, is the coupling between precision livestock farming technologies and artificial intelligence. So in this short picture or figure, you can see how we get all the information from the sensors. As I have said before, we get the data or the big data of the massive data collection activities that we do at the individual or group scale in the barn. To this big data, we apply some machine learning algorithms or artificial intelligence algorithm. And then what we do is we get a solution for the farmer. So we can help making better decisions to the farmer by using the data and artificial intelligence approaches. One example of this is one experiment that we are currently developing here at the university. So as you can see in the picture below, we are using a rearing farm where different dairy farmers of the country bring their young animals Here, this is located in Valencia, so they have a big problem with heat because this is a summer, 365 days a year. So the cows, they really suffer from heat stress. So the farmer installed like a roof, like a shelter for the animals. And we installed some cameras in the shelter. So we can see how many animals they are below the shadow. And also we can see how the shadow, not only when the shadow is at the zenithal point of the shelter, but also we can monitor how many animals they are when the shadow it's on another angle, on the sun is on another angle. So by using machine learning algorithms and artificial intelligence, we can count with a high accuracy how many animals are below the shadow. What we do with this data, combined with the relative humidity and temperature of the farm, we can assess how the animals behave with the sun by using the usage of the shadow as a proxy. So what we can do is assume that if the animals go to the shadow, they have heat stress, and we can see how the animals behave to that. So we are not only looking to the THI in the morning or the heat stress in the morning on the day, on the exact date, we also look into the THI across the whole experimental site. So we can provide the farmer with better solutions. In this case, we can tell the farmer, for example, you have the shadow, maybe it's not enough for the number of animals you have, or maybe the animals, they use the shadow from this THR of above. So the farmer can adjust the management practices based on the coupling between precision livestock farming technologies and artificial intelligence. However, this is not perfect. So right now, precision livestock technology has some limitations that we researchers, policymakers, we need to address. The first of all is that there are some detection limits. Of course, not all indicators can be detected, or not all indicators can be detected in the way we want to by the sensors or the technologies we use. Then the interpretability of the results is also a thing that we need to address. Here we are using artificial intelligence to interpret the results or the measurements we get, but work has to be done here to optimize the algorithms to the data we have. Another aspect that I think that's one of the most relevant things when we are talking to farmers is the high cost and the property of the devices. A farmer cannot afford sensors that can cost 1,000, 2,000, 3,000 euros. So that's something that needs to be addressed by policymakers and providing solutions to the farmers to buy these sensors. Another aspect is lack of connectivity. As you probably know, most of you work on farms, you know that farms, one of the problems they have is that they don't have internet connection, or most of them, they don't have internet connection. And our sensors work to with internet connection, as they do measurements and then they put those measurements into the cloud. So this is something that needs to be addressed. Another aspect is the interoperability of the results or the measurement we get. Most of the brands that we use, they have their own systems and their own way of addressing the data they measure. So we need to work, we researchers together with the company, with the private companies, to make all the data that's collected equal or more or less equal, so we can combine different data sets collected by different sensors in different countries to make a more complete assessment. And last but not least is the battery life. These sensors, some of them, they have the ones that they are wireless in this case, they have solar panels that can be used to recharge the batteries, but some of them, they don't have solar panels. So we and the farmers, they have to be looking every day how the batteries are going, so that we can make sure that the devices, they always have batteries. And this is something that, I don't know, it's not our business, our animal scientists, but other scientists from other fields, they need to start thinking about how make batteries last longer and make the life of the farmers easier. So that was basically my presentation. I want to thank to all the team that we have at the university that really work hard every day to make from the livestock sector a more sustainable sector here in Spain and across Europe and the globe. And I'm open to any question you have and free to answer them. So thank you very much.
Thank you so much, Xavier. Such an interesting presentation. I'm very keen to discuss more. I forgot to mention at the start of the presentation today, the webinar today, if you have any questions, please write them down in the Q&A button here. We're going to take the questions after the presentations and have our discussion. So we're counting on you and your participation so we can get the best of the time here. And so please, you are all welcome to come up with interesting questions. And I'm gonna pass the word now to Mikael, so we can continue the flow of the information here. Please, Mikael, the floor is yours. They were muted.
Yeah, I have to unmute. So yes, so the presentation is visible to you now.
Yes, we can see it.
Okay, very good. Yes. Hello, everyone. My name is Mikael Nørmark from the Aarhus University in Denmark. I'm going to, or we are a part of this pathway project, and especially active in this work package 3. We are in the pathway project looking into the different indicators that has where we measure impacts on farming in different areas, environmental and animal welfare and so on. So we are going to look into these agro-tech innovations. Where do they actually have an influence on these indicators? That work has just started, so there's not much results from pathways, but we have also involved in a previous project called Livestock Sense, where I'm going to tell you a little bit of tell you about some of the results from Livestock Sense, especially where the focus has been on farmers' adoption of agri-tech and digital solutions that we just heard of in the previous presentation. So the Livestock Sense project was funded by different countries, and there were these partners involved, both commercial, semi-commercial partner and university partners as well. Just to show that I'm acknowledging these companies and universities for the work they have done in the project that I'm presenting here. So thank you for letting me doing that. So one part of this research was social research to identify the limitations of these precision livestock farming technology use. So what was done in the Livestock Sense project was that we explored the general attitudes from the farmers, especially focused on these PLF systems. And we also tried to ask questions and understand the reasons for the limited use of the ICT tools, information and communication technology tools, and also in a more quantitative way to look at the requirements to understand the information that is actually supplied by the ICT tools, and also the readiness, the willingness to use these new technologies, and also looking at what is actually locking the farmers to take this step towards PLF and ICT. So that was the main aim of especially this part of the project relating to social research. So I'm going to show a little bit of the results of that particular work. So in the Livestock Sense project, a quantitative survey was started out with a huge questionnaire sent around to these 5 different countries. And it was all concentrated on the pig and poultry sectors. So the selected farmers were done in these 2 categories of livestock farming. So this is one of the results. All the survey results were actually published on this web page. So everybody can now click on the country and get the results of how the farmers actually have adopted technologies and what they think about technologies in terms of PLF and ICT. So I'm going to present some of the outcome of this. But as you can see here, just for Denmark, there were 29 poultry farms and 28 pig farms that were where this questionnaire was sent to, and they replied as well with the information. So so this was just a kind of a distribution of the respondents. There were 121 pig farmers that responded in the different countries. There were no pig farmers from Israel, but there was a few poultry farmers. But this is the distribution from the survey, and it's also divided into poultry. That is the bottom left. In terms of what kind of production system they have in poultry, and to the right, it's also what kind of production system do they have in the different countries in terms of pig farming. So most of the countries have also a small pigs and so on, but yeah. So that was the distribution of the farmers that was announced there. So here we look into some of the results from this survey. As Xavier was mentioning, the internet connectivity is one of the limitations for adopting the new PLF technologies and ICT solutions. So actually, in this survey, the farmers were asked, what kind of internet connectivity do you actually have? And what is obvious from these two figures is that there is actually some differences between the poultry and pig farming. As you can see, for the poultry farming, there's a smaller proportion that actually show that they have no internet connection, where in the pig farming area, you can see that there's actually a pretty large proportion in some of the countries that do not have internet connection at all. So that is, of course, something that has a limitation to adoption of PLF and ICT. Yeah. So what kind of smart devices or PLF technologies and ICT tools did they actually apply to these different farms? And this is just a list of that. Also what mentioned by Xavier, that they have building and animal monitoring systems that was pretty extensive in some of the countries. And they also had these air quality monitoring systems. Again, there's a huge distribution between the countries, and also robotics for especially cleaning and feeding and monitoring in pig farming. There was also some deviation, but again, yeah. And the camera system that Xavier was also talking about, it's also less used in pig farming. So this is just showing that there is a huge deviation between the countries, but some countries have actually adopted some of these technologies a lot. A country like Denmark and also Sweden has adopted a lot of these technologies in the past, but also Estonia, especially in the poultry sector, have also adopted a lot of these technologies. So yeah, so that is some of the results from this survey. And another result from this survey is actually also asked about the plans they have, the farmers. Do they use it now? Do they plan to use it? Or will they not use this these smart technologies or PLF technologies in the future. And here again, there's a great deviation between the countries, but one country that is really deviating a lot is the Israel farmers. But if we look at the Scandinavian and East European countries, it seems like they are somehow using PLF, and they have some interest in planning to do so. There is this level of not to use, you could say. That means they have no idea on how to implement PLF or ICT solutions in some of the farms. But I mean, if you look at the levels, I think it's still positive. And the more applied the technology will be, I think also the more farmers will start looking into it and planning to use it. So if you ask this question in 5 years' time, 10 years' time, I'm pretty sure it will look different. So what did the farmers actually agree in terms of this PLF and ICT tool? Here you can see a big difference between the farmers who is actually using the smart technologies, PLF technologies, and the ones that are not using it at all. So it's just a way of presenting the results to see where is the differences actually between the users and the non-users of PLF. So some of the places or the questions where there was a big difference between the users and the non-users is, for example, it's easy to access the smart technologies on the market. So as soon as the users have adopted the technology, they say, okay, it was pretty easy. But the non-users, they don't know how to access it and get hold of this new technology. Does these PLF technologies operate in a reliable manner? Again, the users, they have some experience, so the rate is too high, and so on. And then there's also something about the costs. Can this PLF technology and ICT tools, can they be applied or in a cost benefit in applying this? There was again a huge difference between that. But again, if you look at the users, they are not 100% sure that there is a very good cost benefit of this technology. But anyway, if you ask this question again when they have used the technology for more years, maybe this percentage will increase. Yeah. Yes, I have to move on. And what is actually a little bit new to science in this livestock census, that we had this SBA research from Austria, who did this application of machine learning to the survey data. So what this SBA research did, they aggregated all the data from all the questions, and then they actually did some principal component analysis to cluster these hierarchies from all the questions, saying, okay, is there actually a clustering into ready to not ready for technology in these questions? Did the farmers actually answer this particular question such that it was able to cluster? Okay, here we can see that the farmers are ready for new technology, PLF technology, or not ready and partially ready. So there were these three different clusters. In that way, they actually selected the most relevant questions for being able to separate all the respondents into these three categories: not ready, partially ready, and ready for PLF technology on their particular farms. And this machine learning using the decision tree model was actually able to predict the farmers' readiness for PLF technologies with an 82% accuracy. So we actually in this project added this machine learning onto the data from this survey. So that is actually an extra level of information that we get from such surveys. I'm running a little bit out of time, so I will just also mention that we did qualitative observations with the early adopters of ICT and PLF technologies, and got more in-depth information about the issues they were actually means in terms of positive and negative impact on their farm management when they did this adoption of new technology. So this is just a list of the particular farms that we use for this survey in the different countries. I will not go into details. We also asked a huge group of farmers that has adopted these technologies some questions to get more in-depth knowledge about positive and negative impacts of PLF and ICT tools. I will just jump directly to conclusions. What we can conclude from this livestock sense and what I've just presented here, there's a lot more results from the livestock sense, is that in relation to our pathway project, in this case, we were actually able to measure and adoption characteristics for readiness for this for new technologies. So we combined the social research, that means the quantitative, we surveyed, we asked a lot of questions, but then we combined the results into this machine learning approach, giving us the opportunity to get some more information out of the data. So that is the conclusion from this part of the livestock sense project that ended last year, by the way. So thank you very much for your attention. Sorry for this 1 minute delay.
Thank you. Thank you so much, Mikael. So interesting. I think we had great presentations. We covered from what are the technologies available, what are the benefits or opportunities and challenges that we have with PLF, and also we came to the implementation part, which is also very important. So I think you did a great job, and I'm very, very happy to hear that. So please, the ones that are here now, if you have questions, you can write them in the chat. I can see that we have 3 questions here. So maybe Xavier and Mikael, you can jump in and answer them. The first one is from Professor Harry Blockhouse. How much is PLF implemented in practice? Does it suit all production systems? This is a very interesting question. What is the reality there? How do you see?
Well, I think that more and more farmers, they are, as Mikael has said, more and more farmers, they are using PLF technologies. I think that there are huge limitations, and the price is one of the biggest limitations. The farmers, at least the farmers we work with, they really think that they are expensive devices. Most of the devices, they are bought using project funds, for example. So it's difficult for them to get the sensors. Once they get the sensors, they are happy with them, and they start seeing a new complete world opens in front of them. It's crazy, and they really like them because the sensors help them making better decisions and to tackle the problems they have in their systems. And the second part of the questions, I think that as for the difference between intensive and extensive systems, there are PLF technologies that can be applied for intensive systems. There are the most of them, but also there are technologies that can be applied for extensive or semi-extensive systems, like, for example, virtual fencing. Virtual fencing is PLF technology that can be use of GPS collars, for example, also can be used in extensive system to monitor the location of the animals and also to optimize the use of the resources that the farmers have in semi-extensive systems. So I think that it's getting more and more popular, and there's a lot of devices for any of the systems that we have.
And I also think that the livestock sense results show that at least approximately 80% of the farmers population that we asked that has already implemented some sort of precision livestock farming technologies. They were pretty satisfied with this. But you can say, does it suit all production systems? I would say no, it does not suit all production systems. It is back to individual farmers' choice in terms of how much workload can you replace manual work, can you replace with machinery and PLF, how much more information and documentation, because documentation is also a very important issue that we found that they really use PLF also for documentation for their production system, not only for themselves, but also for benchmarking and other things. So, but I agree with Xavier that the implementation is increasing also in countries in Eastern Europe and in Scandinavia, and if we have asked also in France and other places, I would say that the numbers probably the same. That's my guess. I mean, these PLF technologies are developed all over Europe and implemented both nationally but also internationally. So we will see an increase in the implementation. That's for sure.
Yeah, thank you. And then that's a good link to the next question on regards animal welfare. What is the actual evidence that PLF improve animal welfare? I mean, I'm an animal welfare scientist, and I know that in the animal welfare world, there is a, how to say, big enthusiasm about PLF, but in practice, what are really the evidence that PLF is improving animal welfare and not just laboring or production efficiency at the farm level? I mean, on the level of the animal, if we focus on the animal, how do you see that?
I can give two examples with the two sensors I have here. For example, with emission concentrations. In pig housing systems, in intensive pig housing systems, ammonia emissions are a big problem because they can cause problems for the breathing of the animals or the air quality of the barns. So by monitoring the concentration of ammonia with these sensors, we are able to regulate the ventilation parameters of the farm, and therefore we can increase the welfare of the animals because we reduce the ammonia concentrations in the barn. That's a clear example, and we really tested, and it works. And the animals, they grow better and with a cleaner air, let's say. And then also with the collars, we have also tested this collar or this kind of collars, not exactly these ones, but with dairy cows in really intensive dairy farm here in Spain. And we use it to assess the panting time of the animals, a panting time as a proxy for heat stress. So we were able to assess or to give advice to the farmers on the number of showers the farmer use in the barn to optimize the number of hours of showers, to increase the potential that they have to reduce panting. So in a simple way, we tell the farmers, okay, you have to shower the animals this time, this time, this time, this time, because if you shower them in these times with this frequency, you are going to reduce panting, and by reducing panting, you are going to improve the animal welfare because you are reducing the heat stress. So I think that there are clear examples of this. There are multiple examples. I think that the scientific knowledge is growing really fast on this regard. And I think that we are going to see really, really interesting things in the following years.
Thank you.
You can also perhaps just add a short comment about the evidence of improving animal welfare. I mean, for the moment, the PLF and the technology is not controlling the farm. It's still the farmers and the employees on the farm that is controlling the animal welfare. The technology is just providing information and decision support. So that's why I think that the question about does PLF actually improve animal welfare, it is a question to me that cannot be answered, because it's still the farmers that are in 100% control of the animal welfare. They get more and more tools to be able to see how the animals, for example, lameness and temperature and other behavioral information that this animal is having some issues, health issues. But if you're not taking action on that, then the animal welfare is still in a bad condition. So that's the it's difficult to answer that question, because we have the farmer in the middle of everything here. So.
Yeah, that's very relevant. What if perhaps might is a bit still a question is like, what are the long-term effects of the exposure of such technologies on the animal, really? So I think there's so much to do in regards animal welfare and PLF, so it's quite exciting. But let's move on. So the next question, it is about if the slides would be available. This is being recorded, and all the attendees will be notified when you can when the video is online. So you will have access to this. Then we have another question. Very interesting presentations from Neil Joseph Tirkett. Very interesting presentations. As mentioned, one of the challenges is interpreting the data. What can farmers do to find partners to interpret data when they are interested to invest in such technology, especially in countries where there is lack of local experts? There are cases where farmers buy PLF technology but don't use them to the full capacity, as there is no one to explain the data they collect. Yeah.
That's a really relevant thing. I think that at least the experience we have here, we as we couple with them and we really collaborate with them really intensively, we help them understand what the results we get from the PLF technologies mean for their decisions and how this can help their management. Some of the systems, they have their own softwares and the farmers can easily see what are the results. But I think that at least these companies, they need to give the farmers some kind of advice on how to use them, and give them also a word of caution when making or implementing directly these decisions into the farm. So I think that that's where we scientists, we can help farmers and make like an intermediate step between companies, farmers. We are in the middle, so we can teach or not teach them by or guide them in their decisions based on the data we obtain. So I think that that's a really relevant thing. We are in the lucky positions that we have a lot of farmers to collaborate with, but I am aware that that's not the case in all the kind of parts of the world. So I think that really there's a lot of work to do there. Giving some information also to the farmers is relevant. We are doing it. We are helping them, and we are making all the things that they are possible to make the farms more sustainable by teaching them or telling them how to make better decisions based on data or the results. So I think that's the way we can help them to make the most of their sensors and of their investments. That at least is an investment.
I agree.
Do you want to add anything? Okay, you agree. Yeah, okay. So the next question is from Christian Stoyan. By adopting PLF and any new tech such AI, aren't we running the risk of further livestock intensification systems, hence further exacerbating the negative externalities associated with the system?
Again, I think it's also a little bit connected to the previous question, because if you're a company providing, let's say, in what we have seen today is milking robots, which is a very advanced piece of technology. AI is also a very advanced piece of technology. If we're taking the milking robot and the farmers, the connection or the relation between the companies providing milking robots and the farmer is that the farmer, he's not the engineer. We should never expect that the farmer will be the engineer. So what the milking robot companies have experienced the last 20, 30 years is that they are responsible. They are taking the responsibility for the milking robots. They are online. They can remotely control these milking robots. They can inform the farmers what to do if something is not working properly. If it's a software issue, then they can do something from remotely. So in the long run, we should be really, really careful about expecting that the farmers are engineers, because they are not. They don't want to be engineers. They should not be engineers. They should be farmers taking care of the daily basis with animals and their employees and so on. So, so I would say no. There's no risk actually for implementing artificial intelligence, because it's again something that is placed with engineers. So the farmer is still having this relation to animals and his livestock or her livestock, but using these tools. But it's not the tools taking over the work by the farmer, the responsibility by the farmer. It's again a supported tool that is having a high intelligence and really helping the farmer to make the right decisions. It's again, there is the farmer in the middle, and the farmer should not be the engineer.
I think that that's a really key point. I think that we have to help them understand and make things easier for them, because they have too many things to worry about, and the least thing they need to worry about is about technology, to be honest. They have a lot of work to do. And also regarding the question of the risk of intensification, there are plenty of technologies that can be used both for extensive and intensive systems, both for pigs and for dairy cattle. That's the thing, or beef cattle. That's the thing I know the most. And there are the systems that, or ruminants, for example, small ruminants like sheep or goats. So I think that's not an issue of PLF itself to increase the intensification of the system, but more about the demand of animal source products that we have right now. So we need to acknowledge that the system is like this. We need to improve the system to lower as much as possible their emissions and their impacts. And I think that PLF technologies, they clearly contribute to reduce the externalities without increasing the negative externalities. That's my opinion. Of course, there are plenty of views in this thing, because this is a really tricky topic, but I think that we improve the animal welfare of the animals. We improve the environmental condition of the farms. We improve the efficiency on the use of the resources. So in a context of lack of inputs that we are living now, we have been living during the last years because of the war. So I think that PLF technologies, they can clearly contribute to reduce, for example, feed waste. That's a key thing. Or in an agricultural point of view, to optimize the fertilization schemes. That's outside of the topic of the talk, but also can help to that. So I think that it's a win-win thing so far.
Thank you. There is a comment from Harry that implemented systems relate mainly to production efficiency, not so much to animal welfare. Do you want to comment on this? Or
No, I fully agree.
Yeah.
But as researchers, we are really trying to also add this other dimension in terms of animal welfare. And actually, I can mention some of the projects that I've been involved in is also related to the safety of handling animals. How can we use this technology to warn the workforce or the employees on a farm about this animal is actually having a strange behavior? It could be a dangerous one to approach, and things like that. Having the technology, the PLF technology, helping us to determine these more dangerous animals. So we can use this technology in many different ways. And I think it's a matter of us as researchers and approaching the companies to try to use the data for other purposes. The data is there. We should just interpret it in another context that is not only production efficiency related, but also some of the other parameters that we are measuring farms in now and also in the future in terms of emissions and animal welfare and other things that will probably come in the future if we can measure it, of course. Yeah. So.
Yeah, thank you for the comment. I'm just going further with the questions here. We have more questions. The next one is, how can PLF advance the transition to extensive, semi-extensive system, sustainable systems? I think this was already addressed in your comments. The next one, it's what's about interoperability? Is there any contact with equipment manufacturers to standardize the communication methods of tools? Thank you for your presentation, Xavier.
This is the million-dollar question also. When we start talking about interoperability, we have to start talking about patents and about software that belongs to the companies. And companies, they are really, really not keen on providing their internal things in general. So what we need to do, we researchers, is to try to convince, that's something really big problem, to convince companies to make systems that the data they collect can be used for other purposes. For example, some of the companies, they use own built softwares to visualize or to download the data in a certain format. That's a big problem, to be honest, because that limits your capabilities to assess that data combined with others. So I think that's something that companies need to do, but we need to force them to do. And not force them, but try to persuade them to do that thing. And I think that we are doing a good job right now. I think that more and more they are, let's say, seeing the benefits of interoperability, but there's still a lot of things to do and a lot of meetings to do with companies. So that's something for the next years.
Something is happening in some other industries that are combining technology for communication, communication, AI, and devices, small devices. For example, for vehicles, you have the teleoperator, you have the company providing the small devices in the buses, for example, logging both the data from the bus, but also the ticket system and so on. They are producing this device. And then you have the AI operator and the data server provider and all these things together. But each of these companies, they are having their own business model, but it's a combined system where they have vendors of the different parts of this system. It's like a precision livestock farming system. There's a lot of small components, devices included in that, and connectivity and things like that. But they are all having their own business model in this setup. So they are all making money. So I think it's a task for us as researchers and innovation in the future to see this big picture. How can these small companies providing, or large companies and small companies, how can they be combined such that we will have this complete system where everything is talking the same digital language, and then they are actually making money, because this is the system for this particular task for PLF purposes. I think we have to think a lot more in this kind of business models and helping. When we are looking into PLF technologies, we should again have in our mind this is going to have a role in a big system where companies can see themselves in the future. I think that is one of the tasks that we have. We are seeing that in other systems. For example, I mentioned with the buses, and also for logging of water use locally in your house. It's also connected to the internet and IoT setup. So the whole IoT sector is doing this at the moment. So I think we should look a little bit more into that.
Yeah. Okay. So thank you. Thank you for addressing all the questions. Thank you again, Xavier and Mikael, for your participation here and to be with us, sharing all your knowledge, and we can have this discussion here in Pathways. I'm going to close this webinar and this debate today, and I would like to thank all participants and invite you for our next webinars that are coming. So please keep up with our social media and with our communication to know more about what's going on. The project is going to a really nice phase now where the results are coming out. So yeah, keep tuned. And so thank you again, and hope you guys have a great day. Thank you very much.
Thank
Thank
you.
you.
Thank
Have a
you.
nice day.
Bye-bye.
Bye.